everyone, welcome to Inside the Sciences. I am Sheena Burhal and I will be your host. And I have a question for you. Have you ever wondered how sterile medicines like injectable drugs or vaccines reach to you safely without a single contamination? Imagine if a tiny vial or a syringe is exposed to bacteria, to dust, or even to a tiny drop from someone's cough. Imagine what could happen. The truth is, the smallest exposure could make a huge difference. This is where contamination control strategies come in by using clean rooms, strict protocols, and specialized equipment that keep every product safe. Now, in today's episode, we're going to dive into the behind the scenes of pharmaceutical production so that we can explore how these contamination control strategies safeguard our sterile medicines and why they matter more than you might think. We are joined today by Dia Novisicarini, a product management executive here at Esco, to walk us through how contamination control strategies actually work. Hello, Dia. Welcome.
Hello, everyone.
Welcome to Inside the Sciences. Okay, so now we're going to talk about contamination control strategies. And my first question to you is, we have the term clean room, and it's a bit technical. So can you tell us in simple terms what we mean when we say clean room?
Okay, you could imagine you are in an environment right now, but clean room is like a specially designed environment, but equipped within the regulation of air filtration system, humidity, temperature, and also access. So it's already controlled in here, and also it's for manufacturing like pharmaceutical manufacturing, medical devices, and also laboratories, but especially for maintain our product safety.
All right. So let's say if the conditions for clean rooms, they're not maintained, what could be the risk?
If the clean room conditions are maintained well, like we don't maintain any pressure or maybe humidity, it could pose a serious risk to the product, like final product, as I said before, like medicine, or maybe could disrupt or harm to the patients, and could leading into a bigger impact, like a product rejection, batch rejection, product recalls, and also regulatory non-compliance. So this is why we need to maintain our clean room conditions well.
All right, very well. So when we also have what we call the CCFIB, this is the cross-contamination facility integrated barrier, right? And then we have the clean room air showers. So can you tell us how this CCFIB work and what's the role of the clean room air showers?
Okay, basically it's already on its name, barrier. CCFIB like a barrier between clean rooms for a different grade or maybe the same grade, but for material and also personnel transfer. And what makes it different within the clean room air shower is the clean room air shower specifically for personnel transfer only, but it's also equipped within the high velocity HEPA filter air jets, so it could at least reduce the airborne particles from the operator from moving into the another room. So basically, clean room air shower is part of CCFIBs.
Okay. Now I truly understand, the difference between the two. Now, can you give us like a real life analogy of that shows why, clean rooms matter?
Okay. It's like something we should always do or used to do for almost every day. Like when you prepare a meal, you need to wash your hand, ensure that the equipment, the utensil, the ingredients are well enough or clean enough, and also ensure the table, the pan, kind of like that. So when you already finish your cook or meal, you believe that this kind of food is safe to eat and also ready to eat for yourself. The clean room within the proper gowning, cleaning, contamination control, like the maintained one, it's like for us to ensuring that the final product is ready to deliver to our patient and no harm to the patient as well.
That's actually a very good analogy with cooking. All right. So now let's talk about the rules for entering and, for transferring materials. We have the tools. So we have the pass boxes and we have the transfer hatches. So why are they so important in clean rooms?
Okay, basically pass boxes and transfer heads are still part of CCFIBs and also for a material transfer, and also several of the one already equipped within the air filtration system for reducing the airborne particles. But why pass box is so important? Because as we know that clean room is very strict about the airborne particles. After all, this is why a layer of pass boxes is to preventing like the cross contamination between the clean rooms.
Okay, so we also have what we call the Esco pass box or the EPB, and we have the SPB, the static pass box. Can you tell us the difference?
Okay, basically SPB is like a more advanced one rather than the EPB because it's equipped within the electromagnetic interlocking door, and also kind of like the interior is like a cover corner for easy cleaning like this.
Yeah.
So we don't have any efforts to clean that up.
Oh,
But
yeah.
for EPB, it's like more simplest one. It's like using the mechanical interlocking door, and also the inside is non-covered corner. Yeah, unfortunately, we need a lot of efforts or put a lot of efforts to clean that
To
up.
clean, yeah.
But basically, both of them are used for material transfer, but especially for different grade of cleanliness level. And also there is no air filtration system, that's why.
So between the two, EPB is simpler.
Yeah.
All right, so we also have the dynamic pass boxes, and we also have the dynamic floor laminar hatches. So can you tell us also the difference between the two?
Okay. We move forward like DPB and DFLH is like a more advanced one because it has air filtration system inside. So it could comply within a material transfer for a different grade of clean room setting. So what makes it different between them is the DPB is well mounted, so we need support stand.
Yeah.
For the kind of pass boxes, but for the FLH is wall mounted, so we don't need any support stand. But if the
Okay.
client wants to deliver the materials using some kind of trolley, so we could recommend the DFLH instead of the DPB.
Okay, so we talked about those pass boxes, and in terms of like if a client would is to buy this equipment, why would they choose DPB and DFLH over EPB and SPB?
Okay. That's basically based on the clean room setting or cleanliness level. Like when the client wants to move the material between clean rooms within the same grade of cleanliness, we just recommend or suggest the SPB or EPB because there is no need to reduce any airborne particle, right? But if the client wants to move the materials between clean rooms within different grade cleanliness level, we could recommend the DPB or DFLH because it has air filtration system, so the cross contamination is less to happen. That's
So
why.
ultimately, it would depend on the client's needs.
Yeah.
Right. Okay. So how about if, say, the transfer procedures are not followed properly? What could happen?
If the transfer procedures are maintained well or followed well, like not maintain the interlocking system, not maintain the air filtration system, the risk like the cross contamination could be happen. Even we know this, right?
Yeah.
It's really small, and also leading to disrupt the batch or whole batch production of the medicine or maybe medical devices, leading to product recalls. Yeah, that's why it's really
Important.
dangerous and important.
Then we follow this protocols. Now we have what we call the super strict, rules when it comes to pass boxes. So can you tell us like an analogy again why this, so people could understand why, these layers of pass boxes matter?
Okay. I would like to ask you, like, have you ever seen or watched movie like spaceship movie?
Yeah.
I think if you could remember, there is some kind of clean airlocks, I believe.
Yeah.
Yeah, clean air elevator, and then that kind of rule of that kind of clean air elevator is like our pass boxes because we couldn't open one side of hatch. and then the other heads at the same time, right? Because it will ruin the other environment, like it could harm or potential risk to our astronaut. Yeah. So that's why a layer of pass boxes is quite important, because we don't want to disrupt the other environment of the clean level that already been comply within the ISO class 5 might be. And then that's why layer of pass boxes is quite important.
It's actually, I really like your analogy when it comes to a spaceship movie. I like that one. Okay, now let's talk about this, the contamination, which are like, invisible enemy, like everywhere. So particularly in pharmaceutical industry. So in the pharmaceutical world, what's the most common form of, invisible contamination that people might underestimate?
I think the most common one is microbial contamination, right?
Yeah.
Like microbes or maybe spores or maybe other microorganisms. They, even though we don't really notice or it's not visible to our eyes, but it's still have something like a risk to our body or maybe patients.
Yeah.
So we need to maintain our clean rooms from this kind of contamination after all.
All right. So I've mentioned earlier at the very beginning that even the smallest exposure could make a huge difference, particularly in pharmaceutical production. So can you tell us why that is the case? Why is it that even a tiny contamination is dangerous for drug safety?
Okay, even a tiny amount of, as I said before, microbial contamination leading to, like influencing some immune system or maybe influence some allergic condition from the patient. And then at the end will be costly a lot for manufacturer, like product rejection, product recalls, and regulatory non-compliance. So this manufacturer need to cover all of that stuff,
It's really important that
It's really important.
we don't have a single contamination
Yeah.
when it comes to drug production. Okay, so we have the biopass pass through, right?
Yeah.
So specifically, how does this biopass pass through specifically block contamination during material transfer?
Okay. Basically, biopass is like super advanced in our CCFI-based product, because it equipped within a biodecontamination system, like using hydrogen peroxide, really dangerous, reactive like that. And then also already achieve a high log of reduction of bioburden, and also could comply with ISO class 5. That's why it's really important and super advanced. Also, we have a features like inflatable seal door, so we need to ensure there is no leak happen during the biodecon, as we know that we don't want to any pose risk to our operator or patient itself when use this kind of biopass.
Okay, that's actually something that's very interesting. Now, if you're going to explain to someone that's outside, the production floor, explain to someone what everyday situation best illustrates how contamination can, leak, can sneak in the production.
I think it's like something that happen for us for almost every day. Like when you go to office and then someone or maybe your friends already feeling unwell, and then suddenly they cough or maybe sneezes, and you don't even notice that this kind of droplets already contaminated you. You know. And then somehow in the next day you maybe feeling unwell, to like, oh my god, I'm so sick. Oh, maybe this is because of contamination of that kind of droplets. Contamination is like that. We don't we thought we even notice it could disrupt a whole batch of production, and at the end, it could harmful to our patients.
All right, so it's even really the tiniest exposure could make a huge difference. Okay, for my last question to you, what's one best practice that every pharma professional should remember so that they can minimize contamination risks?
I think the most standard one is follow strict aseptic protocol, right? But for this focus, using layer of pass boxes for material transfer is kind of important too. And also maintain the basic one, control of contamination, like aerosol particles, the microbial contamination. Also, the last one is when we want to do the material transfer, but for advanced or maybe infectious, we could use the biopass, but we don't. We need to follow the biodecontamination system or cycles. We need to follow that kind of process, so we could at least reduce the cross contamination to be happen.
All right. So, you know, I learned so much from you today, Dia. So, thank you very much for sharing your knowledge about contamination control strategies. And I hope you guys have taken notes because those are really very insightful what Dia shared to us. All right. Thank you very much, Dia.
Thank you for having me.
All right, so now we know how contamination control strategies are very important when it comes to pharmaceutical production. If you want to know more about these clean room technologies, visit www.escolifesciences.com. Once again, this is Sheena Berhal and this has been Inside the Sciences. Thank you for watching and don't forget to subscribe. Bye!